Another important feature of functions that we want to talk about is called end behavior. So in your notes, follow along with me. It says the end behavior of a function is a description of what happens to the function at the ends of the graph. In other words, as x approaches positive and negative infinity. To describe end behavior, we will use limit notation. So it's important for you all to understand how to read this. This says the limit of f of x as x approaches infinity. If I were you, I would pause the video and say that again out loud. The limit, that's this part, of f of x as x approaches infinity. This is asking us to say what happens to the function as you move to the right without bound. The other limit that you'll see for end behavior is the limit of f of x as x approaches negative infinity. This is asking us to say what happens to the function as you move to the left without bound. So let's practice on these two functions. The first thing you're going to do when you're asked to determine the end behavior is to write your two limits. This is a really important skill to have. You need to write your end behavior the exact same every single time, or else I'm going to mark points off. So I start with this LIM for limit. Then underneath it, I do an x arrow positive infinity. Of my function, we're going to call f of x. So this says, instead of an equal sign, I'm going to put an arrow. This says the limit as x approaches positive infinity of f of x. And then I need a second limit to talk about the other side of the function. The limit as x approaches negative infinity of f of x. So let's go back to this first limit. All I'm asking is, as the x values get really big, what's happening to the function? So when I look at my graph, as my x values get bigger and bigger and bigger, or as my eyes move further and further to the right, the function, or the graph, continues to go up, 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 up. Meaning that as the x values get infinitely big, the function, or the y values, go up towards positive infinity. On the other side of the graph, as x gets infinitely small, or as x approaches negative infinity, so as my eyes move to the left, we notice that the function goes down. So as x gets infinitely small towards negative infinity, the y values, or the function itself, also goes down to negative infinity. Let's try another one. So again, I'm going to start by just writing my limit notation. The limit as x approaches positive infinity of f of x. And secondly, the limit as x approaches negative infinity of f of x. So for my first limit, I want my eyes to move to the right of my graph. This is when x goes to positive infinity. As the x values go to positive infinity and my function gets really big, I notice that my eyes also start to go down towards negative infinity. For the other side of the graph, as x gets infinitely small, or as my eyes move to the left, I notice that my function continues to go down as well on the other side. So in this case, both limits approach negative infinity.